The first thing I like to do after I make a table and fill in the information that I know is I like to break this circuit down in a straight line, and I'll show you what I mean in just a second. So let's break it down and see what we know. We know that R1 is 8 ohms, so I'll write in 8 ohms here. I know that R2 is 12 ohms, and I know that R3 is 6 ohms, and I know that the total current through the circuit is, 3 amps. And I know that because there's nothing in between this line and the battery. There's no branches, so this must be the total current. So how can I take this and draw it out in a way that's going to make it easy for me to understand? And I'll show you. I'm going to start at the positive side of the battery, which is where the current flows from. Actually, electrons flow the other way, but they hadn't invented electrons when they, or hadn't discovered electrons when they started doing circuits. So the current, we take it as flowing this way, and the first thing it does is it goes to R1. So in a line, if I start at the positive end of the battery, the first thing that happens is I go to R1, which is 8 ohms. And then I get to a branch right here, which generally I'll circle that first branch to call attention to it. I'm not going to circle it up there because I'm on my cardboard. But that's where it splits. And it splits into R2 and R3. So I'll write the smaller number up on top. So I'll write my R2 up here, which is 12 ohms. And then I'll write my R3 down here, which is 6 ohms. And then what do? They come back together again, and they head on back to the battery. So and they split, they go through their separate resistors, and then they come on back here, and they come back together again. All right, and head back to the battery. So now I've got a series circuit and a parallel circuit in series with each other. So we see how that is? So this and this are in series. So what I can do is I can solve the information for the parallel circuit and pretend like it's just a single resistor, and then treat this like a series circuit, can't I? So first I'm going to come over here and I'm going to identify, I know that R2 and R3 are parallel to each other, so they're going to have the same voltage. So I know that these two are going to have the same voltage. And I know that the current flowing through R2 and through R3 are going to add up to the total current. So I know that this one and this one are going to total, these two are going to total what's flowing through R3 and what the total is. And I know that this guy right here, wait a minute, what am I doing? I'm doing the wrong numbers, aren't I? Sorry. Let me do the, let's see, R2 and R3, those are the ones that are going to be the same. And I know that these two right here are going to add up to equal this. Okay? So these two right here have some resistance, which I'm going to call RP. That's the parallel resistance for the parallel part of this circuit. So what is this resistance? What is this RP? Okay? So 1 over RP is equal to 1 over 12 plus 1 over 6. Would everybody agree with that? What's the common denominator here? 12, right. So that's the same as 1 over 12 plus 2 over 12, which is equal to 3 over 12. So 1 over RP equals 3 over 12, which means that RP over 1 must be equal to 12 over 3. And what is 12 divided by 3? 4. So this is equal to 4 ohms. So now I just have a series circuit. I have an 8 ohm and a 12 ohm, right? I can treat this like a black box, pretend like that I don't know what's in there. I just know that it's a resistor that has a resistance of 4 ohms. All right? So 8 ohms plus 4 ohms is how many ohms in my series circuit? 12, right. So let me plug in my 12 ohms here. And I can write 4 ohms over here because that's what this is, right? Together is 4 ohms. if I know 12 ohms and I know 3 amps, can I get my total battery voltage? 12 times 3 is what? How much? 36 volts, right. 36 volts. And I know that this 3 amps is also flowing through that resistor up there. It must, because there are no other branches. So what is 8 times 3? 24 volts. And I know that the voltage across these plus the voltage across this must equal the battery voltage. So if the voltage here is 24 and the total voltage is 36, what's the voltage here? 36 minus 24 is what? 12. And it's the same for both, isn't it? Because this is parallel. 12 volts divided by 12 ohms is how many amps? 12 volts divided by 6 ohms is how many amps? Does 1 plus 2 equal 3? Most of the time. Everybody get it? A little harder than parallel, but not a whole lot if you draw it out like this and solve the small part, solve each part, and then kind of tack it onto the rest. There we go. All right, is this the next one? Yeah, okay. Make sure. All right, let's start by writing down what we know. We know that R1 is 30 ohms. We know that R2 is 30 ohms. And we know that R3 is 5 ohms. We know that the total voltage is 40 volts. And that's it. That's all we know. So let's kind of linearize this. So if I start at the positive end of the battery, that's the big end of the battery, and I'm coming out, the first thing that happens is I hit a branch. And I split into R1 and R2. So there's my branch. I have R1. I have R2. Then they come back together again. And I hit R3. And then I come on back around to the battery. So R3 is 5 ohms. R1 is 30 ohms. And R2 is also 30 ohms. And I gave you a shortcut when you have two resistors that are identical to each other in parallel. The resistance is how much? How much? I thought I heard somebody say it. It's half. 1/2. So let's prove it, since you can't remember it. So resistance in parallel, 1 over that resistance in parallel is going to be equal to 1 over 30 plus 1 over 30. What is 1 over 30 plus 1 over 30? 2 over 30, right. Which means if 1 over the parallel resistance is equal to 1 over, is equal to 2 over 30, then that means the parallel resistance over 1 is equal to 30 over 2, which is equal to 15 ohms, right? So if you have two identical resistors in parallel, the resistance of that parallel part of the circuit is exactly half of the value of the resistors. Okay? So we know that this part right here, which I'll just call RP, or we could call this, sometimes I'll do this, I'll call it R12, because it's the parallel thing made up of resistors 1 and 2. We know that its value is 15 ohms. Well, now that I can treat this like one series resistor, right? I can pretend like it's one big series resistor in series with this. I can just add the resistances up. So I have 15 ohms plus 5 ohms, right? So this right here, this is the parallel resistor, which is 15 ohms. 15 plus 5 is what? 20 ohms, right. So now that I know that I have 20 ohms of resistance and a 40 volt circuit, can I then calculate my my current? Right down here. 40 divided by 20, 2 amps. Right. Now, 2 amps is flowing through the circuit. Where does 2 amps have to flow? It has to flow through here, right? There's no other branch for it to flow through. So I know 2 amps is flowing through this 5 ohm resistor, R3. It has to be, because there's no other place for it to go. Which means I can calculate the voltage drop across R3. 5 ohms times 2 amps is how many volts? Yeah, 10 volts. Now I know that the voltage drop across R1 and R2, since they're a parallel circuit, they split and then they come together, the voltage drop across this circuit is the same on R1 as it is on R2. And I know that the voltage drop across R1 and R2 plus the voltage drop across R3 has to equal the total voltage drop. So what's the total voltage drop across R1 and R2? 30, right, it's 30. So it's 30, 30, same thing. I can call this 1 if I want to. I can call this 30 because it's a parallel circuit. Knowing that it's 30 volts means that I should be able to calculate the current. 30 volts divided by 30 ohms is 1 amp. And same thing here, 1 amp. 1 plus 1 is equal to 2, right? And we're done. All right, let's look at the next one. Yep. Let somebody write something down. Gives me time for coffee. Okay. Let's move on. All right, on this circuit, what do we know? We know, well, we have 4 resistors. R1 is 5 ohms. R2 is 6 ohms. R3 is 4 ohms. And R4 is 10 ohms. We also know the total battery voltage is 20 volts. And that's all we know. Now this one is a little bit tricky. So I'm going to draw it out. We have, starting on the positive side of our battery, the first thing that happens is we go through R1. So here is R1. Now we come to a split, which I would circle. And that split goes up to R2, and the other direction it goes to R4. But after R2, what happens? R3. We have another resistor here, R3, and then the circuit comes back together and continues on to the battery. Okay, so we split here, we go to R2 up there and R4 down here, through R3, and then we come back to the battery. So what we have here is a small series circuit inside of a bigger parallel circuit. Everybody see that? So let's solve the little series circuit inside first. R2 plus R3, we can add those together in a series circuit, can't we? So R2 plus R3, that's 10 ohms, right? So R2 plus R3 is 10. Now, so if this is 10 and this is 10, we have a 10 and a 10 parallel to each other. When we have two that are identical, what is the overall resistance? Half, yeah. So that's this right here. This is the parallel circuit, and it has a resistance of 5 ohms. Now, this circuit is in series with R1. This is 5 ohms, and this is 5 ohms. 5 ohms in series with 5 ohms is how many ohms? How much? 5. This is 5 ohms in series with this 5 ohms. And series, we do what? Add. So 5 plus 5 is? Yes, 10 ohms. 10 ohms. So now I know the total resistance of the circuit, 10 ohms, and I know its total voltage, 20 volts, so I should be able to calculate the total current. What is the total current? 2 amps, right. Is there any place where that 2 amps must be flowing? Yeah, through R1. It's got no choice. So it all is going through R1 for sure. So if it's all going through R1, I should be able to calculate the voltage drop across R1. 5 ohms times 2 amps is how many volts? 10 volts, right. So we have 10 volts across R1, and that means we have 10 volts across this circuit. Now, the problem with this circuit is that this is parallel, or a series that is in parallel with this. So, if 10 volts plus the parallel circuit has to equal 20 volts, what is the parallel circuit? 10 volts. Okay, but this is a series circuit, so they have to add to be 10 volts. So let's work on that a little bit. So I've got 10 volts here, and I know that R4 is 10 ohms. So what's the current flowing through R4? How much? 1 amp. And if the total is 2, then I know that the other one has to be flowing through both of these, right? If 1 amp is flowing through here, then 1 amp must be flowing through here, right? So I know that this is also 1 amp because these two are the same. 1 amp. Okay? Now I can get the voltage drop across each resistor. I know that combined they have to equal 10. 6 ohms times 1 amp is how many volts? 6 volts. 4 ohms times 1 amp is how many volts? 6 volts. 6 volts plus 4 volts is 10 volts. We have 10 volts across here, 10 volts across here, but it's broken up into 6 and 4. So you see how we did it? We solved for the smallest, most innermost part, which was this one, and then solved this one, and then solved this one. All right, next. This one's a little easier. You have a question? Yeah. So parallel is when there's a split. When we see a junction like this and it splits, okay, the current comes out of the positive end of the battery. And it goes this way. And as long as it's going this way, it's all going this way. But when it gets to this point, it can go this way or this way, can't it? So that split right there, both sides are going to have the same voltage because it's the same wire, but we now have two different places the current can go. It can either go up here or it can go down here. So these two are in parallel to each other. Well, now they all come back together. So now we're back in series again because there's only one path. Okay? Anytime there's more than one path, it's parallel. Think about a river. It's flowing down. That's all in series, right? But if it splits to go around like an island, how much water goes on the left side and how much goes on the right side? We don't know. It depends on how big the river channel is, right? So some goes on one side, some goes on the other. Those are parallel. Then they come back together again. Okay? So let's take a look at this one. We come out of the positive end of the battery. So we start here. And the first thing that happens is we split into R1 and R2. So I'm going to go up here and do R1, down here, and do R2. Then we come back together again on the other side, and we go through R3, and then through R4. So we have R3 and R4, and then we go on back to the battery. So R3 and R4 are in series with R1 and 2, which are parallel. So let's make this into a single resistor first. Okay, let's make this into a single virtual resistor. So we have, this is 4 ohms, and this is 4 ohms. And what do we know when we have two resistors that are identical, that are in parallel? Half, right, so half of 4 is 2. Okay, so I'm going to call this guy R12, and it's equal to 2 ohms. And it's a pretend single resistor. And that is in series with R3 and R4. And I didn't write all this down yet, did I? So we'll come over here. R1 is 4 ohms. R2 is 4 ohms. And we just determined that together these are 2 ohms because this is in parallel, right? We have R3 is 6 ohms and R4 is 7 ohms. And we know that our total current is 4 amps. And that's all we know. But now we can add up the resistors that are in series. So our RP or R1 and 2 is 2 ohms plus 6 ohms plus 7 ohms gives us a total resistance of 15 ohms, correct? So now that we know our total resistance is 15 ohms and we were given 4 amps of current, we must be able to calculate our total voltage. 15 times 4, 60 volts, right. Now, where does that 4 amps of current have to go through? Right, R3 and R4. So R3 and R4, we can go on and fill in the currents for those. That's 4 amps and 4 amps. So knowing that, we can get the voltage drop across those. 6 times 4 is 24 volts, and 7 times 4, 28 volts. And we know that the voltage across R1 and R2 has to be the same. And we know that it has to be the difference between 60 volts and these two. Right? It's whatever's left over. So 60 minus 28 is 32. Minus 24 is 8. Right, so this is 8 volts. Now we can calculate the current. 8 volts divided by 4 amps is, 4 ohms is 2 amps. 2 amps. And do those two add up to equal 4 amps? They sure do. And since we know that they're both the same resistance, we know that the current should be split evenly. If they weren't the same resistance, they wouldn't be split evenly, but they are. All right. Next. Oh, getting easier now. Back down to only 3 resistors. So let's write down what we know. battery up here, we don't know the voltage. R1, that's 2 ohms. And R2, we don't know, but we do know its voltage, 4 volts. And it appears that we know the current flowing through R2, since there's no other place for it to go, is 2 amps. And we know R3 is 2 ohms. And we know the voltage drop across R3 with the trusty voltmeter. Right? I take the voltmeter and I put it on either side. It reads 8 volts. So I have 8 volts right here across R3. So there's some things I should be able to fill in almost immediately on my table. Anytime I got 2 things in a row, I can solve for the third thing. So 4 volts divided by 2 amps is how many ohms? Right, so R2 is 2 ohms. 8 volts divided by 2 ohms is how many amps? Okay, so I'm getting there. Where does everything... Oh, wait, everything flows through here, through R3, so that means that the total also has to be 4 amps. But we still don't know the battery voltage. Is there anything that we know about the voltage of R2 that can help us? R2 is in parallel with R1, isn't it? So don't these 2 voltages have to be the same? So that means that this is also 4 volts. And if that's 4 volts, then 4 volts divided by 2 ohms is 2 amps. And since these are in parallel, these 2 have to equal the total, right? Now, 4 volt plus 8 volt gives us how many volts? 12 volts. 12 volts divided by 4 amps gives us 3 ohms, right? Because we know 2 plus 2 plus 2 equals 3, right? All right, so why is that? And that's because these 2 are in parallel. And when we add those 2, 1 and 2, if they're both identical to each other, then the total is what? Half, right. So this is 1 ohm combined, right? So 1 plus 2 is 3. That makes a little more sense. All right. Which one is this? Is the last one? Just in the nick of time. All right. So let's go on and fill in what we know. The total is 30 volts. R1, the voltage is 6 volts, but we don't know the resistance. R2 is 6 ohms, and R3 is 12 ohms. And these 2 together are in parallel, so we can solve for that. This is unknown. Everything else is unknown. So let's go ahead and get started. We start, and the first thing that happens when we come out of the positive end of our battery is we go through R1, and that's our unknown. Then we hit a split where we go to R2 and R3. So R2, R3, then our split comes back together again. So it splits here, goes out here, comes back together again, and returns to the battery on the negative side. So we can solve these. We have 6 ohms and 12 ohms. So we should be able to solve this R23 or RP and solve for what that is. So we'll say 1 over RP is equal to 1 over 6 plus 1 over 12. What's the common denominator? 12, right. So that's equal to 2 over 12 plus 1 over 12, which is equal to 3 over 12. So 1 over RP equals 3 over 12. So RP over 1 is equal to 12 over 3, which is what? 4. Right. 4 ohms. So this right here is 4 ohms. So we got 4 ohms and an unknown ohms. We have 30 volts and 6. What does that, for the parallel circuit, these two must be the same, right? So 2 and 3, the voltage across 2 and 3 must be the same, and the voltage across them plus this must equal this. So what's the voltage? 24, right. So this is 24 volts. Now we can calculate the current through each of these two resistors. 24 volts divided by 6 is how many amps? 4 amps. And 24 volts divided by 12 is how many amps? 2. And so what's the total current flowing through these two? That's 6 amps, right? And if that's 6 amps flowing through those two, then it's 6 amps when they come back together again, going to the battery, which means the total current is 6 amps as well. So we know that 6 amps flows through here and 6 amps flows through here. That just leaves us 2 more spots, which we can get to with a little bit of math. 6 volts divided by 6 amps is how many ohms? 1. And 30 volts divided by 6 is 5 ohms. And we can do that because 1 plus 6 plus 12 equals 5. Oh, 1 plus 4 equals 5. Right. Got it? It's easy, isn't it? These are not terribly complicated. I really like drawing them out like this. When you draw them out like this, it allows you to solve for the smaller parts and see the smaller parts that you need to solve for before you move on. A good extra credit question would be something like this. Yeah. If I gave you all the values for these resistors, could you solve for the resistance of the circuit? It'd be easy. Look. Okay. So solve for these two, okay, to make a single resistor. You can solve a parallel resistor, right? Okay, now put those in series with this one. So now that's one resistor. Yeah, now solve for this and put them in parallel. Put them in series with these guys, put these together, and then these together, and now you got 3 resistors in parallel. And do it like that. Okay? Something like that would make an excellent kind of question for like extra credit on a test.